U.S. Physics Olympiad Year 2024 F equal MA. This year, as usual, 75 minutes were given for 25 problems. If you want to stay up to date with interesting Olympiad problems, subscribe to this channel. I offer private tutoring for Physics Olympiad preparation. I currently have openings. There is a discount for group classes. Message me if interested. My email is fred1996@hotmail.com. Problem number 1. An archer fires an arrow from the ground so that it passes through two hoops, which are both a height h, above the ground. The arrow passes through the first hoop 1 second after the arrow is launched, and, through the second hoop another second later. What is the value of h? Solution for the problem number 1. Obviously the times t1 and t2 satisfy the equation gt square over 2 minus v0 t plus h equals 0, where v0 is the initial upward velocity. Therefore, we have equation 1, from which we read off equation 2. Plugging in the numbers gives h equal 10 meters. Alternatively, notice that if the arrow is at the same height at time t1 1 second and t2 equal 2 second, then it must have reached the top of its trajectory at time t equal 1.5 seconds. So it was launched with vertical velocity 15 meters per second, in the first second. The average vertical velocity is therefore 15 plus 5 over 2, which is equal 10 meters per second, giving h equal 10 meters. That was answer B, which is solution for the problem number 1. Problem number 2. An amusement park ride consists of a circular, horizontal room. A rider leans against its frictionless outer walls, which are angled back at 30 degrees with respect to the vertical, so that the rider's center of mass is 5.0 meters from the center of the room. When the room begins to spin about its center, at what angular velocity will the rider's feet first lift off the floor? Solution for the problem number 2. When the rider's feet just lift off, the normal force N from the floor vanishes, so the riders only experience a normal force from the walls. That normal force must both cancel the downward gravitational force mg, and provide the inward centripetal force m omega square r. So we have next two equations. Thus, tangent theta equals g over omega square r. Solving for omega and using tangent 30 degrees equal 1 over root 3 gives omega equals 1.86 radians per second. This is the answer A, and that was solution for problem number 2. Problem number 3. A simple bridge is made of 5 thin rods rigidly connected at 4 vertices. The ground is frictionless, so that it can only exert vertical normal forces at B and D. The weight of the bridge is negligible, but a person stands at its middle, exerting a downward force F at vertex C. In static equilibrium, each rod can be experiencing either tension or compression. Which of the following is true? Answer A. Only the vertical rod is in tension. Answer B. Only the horizontal rods are in tension. Answer C. Both the vertical rod and the diagonal rods are in tension. Answer D. Both the vertical rod and the horizontal rods are in tension. Answer E. All of the rods are in tension. Solution to problem number 3. Points A, B, C and D are in equilibrium. Points B and D are subject to the reaction forces of the bridge support, which, due to symmetry, are equal to F in half. To balance the vertical component on points B and D, force T1 must be a compression force and is equal to F divided by the square root of 2. Further, to balance the vertical component on point A, force T2 must be a tension force and is equal to F. And to balance the horizontal component on points B and D, force T3 must also be a compression force and is equal to F in half. Thus, the forces in the vertical and horizontal rods are tension forces, and in the inclined ones, compression forces. This is answer D, and this is the solution to problem number 3. Problem number 4. A bouncy ball is thrown vertically upward from the ground. Air resistance is negligible, and the ball's collisions with the ground are perfectly elastic. Which of the following shows the kinetic energy of the ball as a function of time? Assume the collisions are too quick for their duration to be seen in the plot. Solution to problem number 4. When the ball is in the air, its velocity is vt equal v0 minus gt, so its kinetic energy is proportional to v squared, which is v0 minus gt squared. It is a concave up parabola. When the ball bounces, its speed stays the same, so the kinetic energy stays the same and there's no discontinuity. The graph of D corresponds to this behavior. That was solution to problem number 4. Problem number 5. A massless inclined plane with angle 30 degrees to the horizontal is fixed to a scale. A block of mass m is released from the top of the plane, which is frictionless. As the block slides down the plane, what is the reading on the scale? Solution to problem number 5. The scale reading is equal to the vertical component of the normal force of the block on the plane. The magnitude of the normal force is mg cosine theta, and the vertical component is cosine theta times this, so the reading is mg cosine square 30 degrees, which is 3/4 mg. This is answer C, and that was solution for problem 5.